All right, hey guys, today we are going to be doing the last lesson of the chapter, which is lesson 5/6, and it is on something called qualitative graphs. Please make sure you have your math book out and ready and your notebook. Don't need a calculator today. So today our learning goal is that I can recognize a qualitative graph. First of all, you're going to be able to tell me what that is, and you can interpret the scenario it represents, as well as you're going to be able to draw a qualitative graph as well. So before we get going, in the last lesson, we learned how to tell if a function is linear or nonlinear. So I want you to look at these 5 problems and quickly just tell me, are they linear or nonlinear? So pause the video and try them. All right, so if you guys look at the first one, you can write that in the form y equals mx plus b. There's no exponent with the x besides the number 1. You could put a 1 here. I can put plus 0. So this one is linear. Number 2, oh, it's got a cubed there, so that is not going to be a straight line, so that is nonlinear. Okay, number 3, if it has a square root in it, it is also nonlinear. And number 4, this one looks pretty good. It's just looks like our normal. Here's our slope, here's our y-intercept, so that one is also linear. If you look at number 5, I have this equation. It is not going to be a straight line because it has that square there. So that is also nonlinear. All right, so I want you guys to take a look at this graph that you see down below. This is an example of a qualitative graph. Now you might notice that there are no numbers on this graph. They do have labels. We have this person that is traveling from their house to the corner store. Okay, so they're going from their home to the corner store, and they're measuring how far they've gone, the distance in miles, after however many minutes have gone by. So I want you to think about, what do you think this story is telling you about the person? What does this part of the graph tell you in green? What does this part right here in blue tell you? What does this part tell you about the person and how far they've gone or how fast they traveled? That's what a qualitative graph tries to tell you. So just think about it for a minute. What do you think this is telling you? All right, so kind of watch the animation as it goes. So the person is starting, they're traveling from home at a constant rate. They're getting further and further away from the store. Right here at this flat part, they're not moving. They must have stopped and took a break, and now they are traveling further away from their home, and they finally arrived at the store, and that is how much time went by. So there is an example of a qualitative graph. Again, the person started here, they're traveling at a pretty constant rate, and they're getting further and further away from their home. Here, time is still going by, but they're not traveling any distance, right? The distance is staying the same. So they must have stopped for a break, and then here they start again after however many minutes, and they're traveling at a pretty good rate, and they keep moving further away from their house until they obviously get to the store. All right, so if you're in your math book on page 305, here's the definition of a qualitative graph. It's a graph used to represent a situation that may not have numbers on it, or it might not be included. So if you look at this one, it shows the time in seconds. Okay, so the axes are always labeled, but sometimes there's not numbers. And then how much of music is downloaded. Okay, so the graph is kind of showing you the relationship as time goes by, how the download's going. So it might start downloading, the percent goes up. Ooh, now the percent stayed the same. So maybe like the internet stopped working very good. And then it was going up again, and then maybe it stopped working, and then it kept downloading. So this is an example of a qualitative graph. All right, so on page 306, if you guys take a look at these different graphs, here's what's happening when you see line segments that look like this. So obviously, if it looks like this, it's going up. If it's a straight line, it's going at a constant rate, and it's increasing from left to right. Okay, if you look at the next one, obviously this is going down, so it's decreasing, and it's a constant rate because it's linear. So that always shows a constant rate. If you see a horizontal line like this, that means there's no change happening. Okay, so it's not changing, it's not increasing, it's not decreasing, it's just staying at whatever it was. Okay, if you see this one down here, it's obviously increasing still, and if it's not a straight line, it's increasing at a varied rate. And that means the rate could be changing. Maybe it starts slowly and then it starts increasing more, but that's called a varied rate. And then the same thing here, this one's decreasing at a varied rate. It's not the same rate. If it was the same rate the whole time, it would be a straight line. Okay, so constant rate is straight. If it's varied, it will not be straight. So let's look at example one. Example one, analyze qualitative graphs. It says the graph displays the water level in a bathtub. Describe the change in the water level over time. Okay, so you can see that this is the time, and here's what the water level is. All right, so if we start by looking at the water level, it obviously starts at 0. So at 0 seconds, the water level, there's no water. Okay, obviously right here, it is increasing or going up at a constant rate because it's a straight line. So in the first blank, we can fill in increasing, or increases at a constant rate. For a period of time right here, there is no change. So the water level is just staying the same. Time's going by, but there's no water getting added. Then here, the water level starts to go down, again, at a constant rate. So it decreases here at a constant rate, and then here it would be empty again. Okay, so that would be how you could describe what is happening. All right, page 306, let's try the check. It says the graph represents the revenue from a local clothing store, so how much money they're making over time. Could you describe the sales over time? So how are they changing? Okay, so I would say the sales start at 0 here, and they're increasing. Now this kind of looks like a straight line here, so at that part they're increasing at a constant rate. Okay, then they're decreasing. This one sort of looks like a curve, so I would say maybe at a varied rate for just a little bit. Then they increase at a varied rate. I think these are all supposed to be curves. Okay, then it kind of stays the same for a little bit, and then it goes up. So the next thing we're going to do is we're going to learn how you actually sketch a qualitative graph. Okay, so they're going to give us information. We're going to actually try to sketch it. So we have Charlie's speed over time. So you can see that they labeled it first of all. They put time down here, and they put the speed here. Okay, so it says Charlie is riding his bike. Okay, so he starts riding his bike. He speeds up, then he rides at a constant rate, and then he slows down. Can you sketch a graph that shows that? So if he starts riding his bike and he's going, he speeds up, so that means he kind of goes kind of fast, and then he rides at a constant rate. So that means his speed is not changing. And then his speed slows down at a constant rate, we'll just assume, so it starts going down. That would be a good sketch of the graph. All right, why don't you try this next one? Push play when you're ready to see what my graph looks like. All right, it says at the beginning of the year, they sell a lot of pencils. So it's obviously increasing. So maybe it starts, it doesn't say at a constant rate, so I'm just kind of making a curve. Then sales drop. Okay, so then maybe it starts going down. It doesn't say at a constant rate, so I'll just kind of go like that. And finally, they're sold at a steady rate. So maybe the same number of pencils is sold right here. And then it keeps going. All right, our next example is with a tennis ball dropping to the floor. So it says on each successive bounce, so like every bounce, it rebounds to a height less than its previous bounce height until it comes to a rest on the floor. It says, can you sketch a graph and then determine if the graph is linear or nonlinear? And then where is the graph increasing or decreasing? Okay, so let's go ahead and look at the sketch that they drew. Well, first they tell you, step one is you always want to draw and label the axis. So we have time and then the distance from the floor. So the ball is obviously starting a little bit in the air, okay? And then they drop it. Okay, it's not going to be at a constant rate, so it kind of goes down. It's going to hit the ground, and it's going to rebound back up. Okay, now the distance from the floor is up again. It gets kind of high, and then it's going to go back down, hit the floor, and then it's going to come back up from the floor, kind of keep going, keep going. This would be a picture of the graph. And I would definitely say that this is nonlinear. Okay, you guys should be able to see that. And you can see where it's increasing and decreasing. Okay, so obviously here it's decreasing, decreasing, decreasing. The increasing parts would be here, 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 the up parts. All right, let's do the check on page 309. I want you guys to try this one and then push play when you're ready to watch it. All right, so the first thing you need to do is label your axes, draw and label your axis. So a person is riding their bike. Okay, so, and it's working with their speed. So this would have to be time as time goes by, and over here would need to be their speed. So you always have to have those labels. So this is the X, this is the Y. Okay, so it says a person riding their bike slowly decreases their speed. So that means that this person, they're already riding their bike. So they have to start up here. Their speed's already going, and it says they're slowly decreasing their speed. So it's slowly going down. Okay, then they quickly speed up. If they quickly speed up, it's going to be kind of steeper. So they speed up, speed up, speed up as time goes by. And finally, they're going to maintain a constant speed. So constant speed would be something like this as time goes by. So your graph should look something like that. Okay, it does have to start kind of up because they're already riding at a certain speed. And then, you know, they slowly decrease, increase, and then constant speed. All right, let's look at page 310 where it says sketch a qualitative graph with values. So it says Louis is biking to his friend Nathan's house. He increases his speed at a constant rate for 2 minutes until he reaches a speed of 6 miles per hour. Okay, after that, he decreases his speed at a constant rate for a minute until he reaches a speed of 2 miles per hour. Finally, his speed increases at a varied rate for 3 minutes until he reaches a speed of 8 miles per hour. It says to sketch a graph. Okay, I want to show you this because it's kind of tricky. So let's start with this. So he's biking at his friend's house. So he starts here at the time, and he increases his speed at a constant rate for 2 minutes until he reaches 6 miles per hour. So here's 6 miles per hour after 2 minutes. So he's increasing, so up, 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 up until you get 6 miles per hour, and that took 2 minutes. So you can see on the graph that went for 2 minutes. Okay, now the next part is in blue. Now he's decreasing his speed at a constant rate for a minute until he reaches 2 miles per hour. So for a minute, I only can go over to the 3. So you can see it's decreasing at a constant rate until he gets to the 2 minutes. And then finally, the last part is he's going to increase at a varied rate. So that means it's going to be a kind of a curve for 3 minutes until he gets to 8 miles per hour. So for 3 minutes, if I'm at 3 minutes, it would be 4, 5, 6 minutes. Okay, and he has to get up to 8. And if it's a varied rate, it would go up, 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 and kind of varied curve like that. Okay, now the last one, let's try this check. So I want you to try this one, and then you can push play. I'll kind of help you get your graph set up too right away. So first, actually, why don't we just get our graph set up? So first, let's draw a graph. Okay, let's label it X and Y. You guys have this whole page to kind of do this. Okay, and I just want you guys to look at some numbers. This is Julian is riding his horse. So he's got the horse's speed and then minutes. So I'm going to come and put minutes down here. And I'm going to put speed up here. Now, this is not going to be a perfect graph because they didn't give us a graph paper in here. I wish they would have. But it looks like, you know, for the minutes, I'm just seeing like 2 minutes, 1 minute, 3 minutes. So I'm just going to count kind of by ones here. So I'll start with 0 in the corner. 1, 2, 3, 4, 5, 6. Okay, I'll even go up to 7. Okay, now for the speed, I see 10 miles per hour. I see 20. So, you know, we at least have to get up to 20. So I'm just going to count baby by 2's here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 20 is all the way up there. Okay, now I want you to try to sketch the graph. All right, so here is the first thing it said. His horse's speed increases at a constant rate, so straight line, for 2 minutes until it gets to 10 miles per hour. Okay, so 2 minutes. I'm going to come way over here to 2 minutes. It's got to get up to 10 miles per hour. So I'm going to put a dot right there. He starts at 0, and it's a constant rate, so I'm going to draw a straight line. Okay, my next part I'm going to do in blue so that we can kind of see this. It increases the speed at a varied rate. So that means it's going to be a curve for 1 minute. So I'm only going to go over to 3 minutes now until it reaches a speed of 20 miles per hour. So it's got to be a curve, and he's got to get up to 20 miles per hour. So I'm going to put a dot up here at 20. It's at the 3rd minute, and it's going to be a curve because it's a varied rate. Okay, finally, I'll do the last part in green. It decreases its speed at a constant rate for 3 minutes. So if I'm at 3 minutes, I got to get to 6 minutes until it comes to a stop. That means it's going to get all the way down here. It's not going to be moving. And it's at a constant rate, so that would be a straight line. So it's going to go down straight like that. You just drew a qualitative graph. All right, so now I want you to actually try some problems, and then we'll practice these a little bit more tomorrow, but I'd like you to try numbers 1 through 8 on page 311 and 312. If you have questions, please ask the sub.